So yeah, hi guys. Welcome to Geeks for Geeks practice. Sorry for the 2 minutes delay. Can you just confirm me that if I am audible? Yeah. Hi Shivam. Am I audible properly and visible? Yeah. Hi Akshat. Yeah. Let's wait for one more minute. I think let's wait for a few more people to join. Okay, guys. Okay. Great. Great. Thank you for the confirmation. Okay. Okay, Milinda. I'm not sure. Like, why didn't you get the notification? Okay. Yeah. Hi Utkarsh. So great. Let me share my screen. Okay. Yeah, and before beginning today's live stream, I would just like to mention few things that there are courses available, okay, on our Geeks for Geeks practice portal. So I'll show it to you in a moment, where you can get a 10% discount also. Okay, I'll give you the coupon code in the comments. Yeah. And apart from that, in my last lesson of three closest sum, few people had doubt, right? Like closest from where we need to approach. I believe Milind also asked, like, if let's say we want to reach to, let's say x is equals to 10 and we are getting 9 and 11. So what should be the answer, right? So there is a note in the question, right, that you need to return the maximum. Okay, so you can check the pinned comment in that video over there. Okay, so that is one thing. And apart from that, let me share the coupon code and the details. Just a second. Second, guys. Yeah, so this is the code, okay? And now let me share my screen. Yeah, guys. So I hope the screen is visible to you. Okay. So these are the courses, okay? Live and online courses. So whatever paid courses you get into these categories, you can apply that coupon code and you'll get 10% discount, okay? So yeah. Great. Apart from that, let's go to the problem of the day that was for yesterday. And the question is maximum and value, right? So let's go and have a look at it. So as you must be aware, like I mostly discuss the question on the whiteboard, but let's have a brief look over there. So it says maximum and value. Great. So there will be an array given to us of n positive elements, and our task is to find a pair, right? Such a pair whose and value if we generate, it should be maximum, and that we need to do, like we need to find out such pairs in the entire array where we get the maximum and value, right? And this is and basically bitwise and operation, right? So that is the reason they have told and is bitwise and operator. Okay, so let's go to the whiteboard and let's try to understand this question. Okay guys, so this is the question. Just a second. Yeah. Yeah, really sorry. Yeah. Okay. So given an array ARR of n positive elements, right? Our task is to find the maximum and value generated by any pair, right? So those of you who are following my live lessons, they must be aware that we discussed one more question with maximum XOR value, right? So there I discussed an approach of bits only. Today we are also going to talk about bits later, like after we move from our brute force to an optimal approach or rather more efficient approach. Okay, but it is not exactly the same. Okay, today's code is going to be, I would say, simpler than the XOR. Okay, maximum XOR code. Great. So let's have a look at it. So given an array of n positive elements, the task is to find maximum and value generated by any pair. Okay, from the array such that I is not equals to j. This is also important, right? Because you cannot just pair the same element with itself. So this is important. And is a bitwise and operator. Okay. So I guess the question is clear. Let's try to understand this sample input. Okay. So we have 4, 8, 12, and 16. So guys, today I'll be writing the numbers mostly in binary form. Okay, means how does 4 look like in binary? Like 100, right? How does 8 looks like 1000, right? 12 is 1100, and 16 is 140, right? These are all binary representation of 4, 8, 12, and 16, right? So if you observe, can I say that if I pick over here 8 and 12, okay, basically these two, 8 and 12. Okay, can I say that I'll be getting the maximum and that is 8? Basically, how does AND table looks like? If you have A, B, and let's say this is your output, okay? So 0, 0, 0, 1, 1, 0, 1, 1, right? So this gives me 0, this gives me 0, this gives me 0, this gives me 1. So for AND to be 1, both of them should be 1, right? So if you observe, if you pick these two, right, then you are getting this bit set, right? So that will give you 8, right? So I hope this is making sense to you guys, right? That's it, like about the question. So if you have any doubts regarding question, you can ask it right now. Okay, like if you are thinking in some other terms or something else. Otherwise, I hope that I have made the question pretty much clear. Because okay, let me put it in more detail, because see, all of these bits is going to be 0, right, when we talk of positive integers. So obviously whatever pair you take other than this, you are going to get a 0, right? So means other than this means let's say you pick this 16 and let's say you pick 12, right? So what will happen? All of them will become 0, right? Okay, great. So guys, if the question is clear, let's move to the approach. Okay. Okay, guys. So a very first basic approach, I think everybody will be able to come up with, okay, or at least most of us. What is that? Let's say the given integers are 4, 8, 12, 16. So let me take all the pairs. For 4, let me first pair it with 8, 12, 16. Okay, for 8, let me pair it with 12 and 16, and 4 also. Basically, I took in the first iteration only 4. Or let me show you the pseudo code. Basically, I'll be checking all the pairs, okay, and I will be storing my maximum and till that point of time. Okay, so let me show it to you. Okay, let's just a second. Let's try this. Okay, I think this is much better. So what I'm saying is, okay, let me first initialize a result. Okay, let me initialize it with 0. For int I equals to 0, I less than, let's say the size of array is n, I plus plus, right? So I am starting from the very 0th index, and now what I want for my j should be always to the right of I, right, to the next element. Don't worry, I'll explain it to you, okay, if it's not clear. J should go till less than n, j plus plus, right? Okay. After this, what I can do? I can update my res, keeping a check that, which is max, math dot max of previous value of res, comma, yeah, O of n square, right? The time complexity, where n is the number of elements in the given array. Okay, res, comma, what I need to do? Let me take it as arr I and arr j, right? A very simple piece of code. Let me close both the for loops and finally return my res. Right, let me just zoom it out a bit so that visibility is much better. right? So I hope this is visible to all of you, right? So this is one piece of code, and as Akshat is saying, the time complexity will be in the order of n square, right? Okay, let me check few more comments if there are any. Okay, fine, guys. So yeah, if this is clear, I hope all of you must be aware of this time complexity. That for each index of the outer loop, the inner loop is going to run n minus one times in worst case. Let's sorry, excuse me. Let's say I pick this. So the very first time my ith pointer will be over here, and j will run for all the n minus one elements, right? But in asymptotically, if you look at it, it's in the order of n square, right? Similarly, after picking 4, 8, 4, 12, and 4, 16 in the first iteration, next iteration, what's going to happen? I is going to increment by 1. Okay, let me write it. 4, 8, 12, 16. Next time we are going to pick 8, 12, and 8, 16, right? And so on, right? This is how it's going to work. Great. And every time we are calculating this ampersand, okay, and comparing it with previous value of res, and if whichever them is max, I'm updating my res, okay, and so on. This goes on. So I hope this code is clear to each one of you. If you have any doubts, do let me know. This is a very basic code. Okay. Now let me try to optimize it, because if you go to the Geeks for Geeks practice portal, it is asking for a time complexity of order of n log m. Okay, what is m? M is the maximum element of the array, so we'll see how we can achieve that. Okay, fine. So let's now discuss what better we can do. So see, what I find is, if you have a look at the numbers, you just need to find out maximum and pair, right? And for maximum and pair, can I say that whatever bits you are comparing, every time you need to have both of the bits to be 1, then only you are going to get a 1. In all the other cases, you are going to get a 0, right? So we need to somehow keep a track of this, like how we can see that, okay, at the two places I can have 1 and 1, right? Okay, so Utkarsh is asking what does, okay, Utkarsh, let me explain it to you. See, what does ARR I ampersand ARR J does? This is a bitwise operation, okay? So let's say for the first time, let me take this example, 4, 8, 12, 16. So your ARR I is going to be 4 because I equals to 0. J is equals to I plus 1. So ARR J is going to be 8. So what happens is this 4 in binary, we can write it like this, right? Binary representation. Similarly, 8, how we can write? Can I say I can write 1 0 0 0? So this ARR I ampersand ARR J basically does your computations in bitwise. So 0 0 ampersand 0, what it is? 0, right? 0 ampersand 0, it is 0. 1 ampersand 0, it is again 0. And over here also we'll have zeros, right? It depends how many bits we are needing in our specific language, right, to store integers. So over here, if we don't have anything, we'll have 0 for positive integers. Okay, I'm talking about positive integers. I'm trying to be as precise as possible. So 0 ampersand 1 is again going to be 0, right? So I hope you get it, Utkarsh, right? What ARR I ampersand ARR J is doing. This is bitwise operation. You can study more bitwise operations. Okay, like there are bitwise OR, bitwise OR. Okay, so similarly, like every time you are going to do bitwise of all the pairs, right? 4 with 8, 4 with 12, 4 with 16, and so on and so forth, right? And keep a track of the maximum so far. Great. So if that is fine, guys, let's move to the better approach. Okay. Yeah, yeah, correct, correct. Utkarsh, Akshar is right. Akshat is right. Yeah. Great. So let's say we have the elements as 4, 8, 12, 16. Now, from here onwards, guys, in order to explain you properly, I'm going to write the things in a binary representation. Okay. So just a second. Yeah. Okay. No comments as of now. Okay. So let me put it in this way. Okay. For 4, if I write, I get 100. Okay. And what's the next number? 8, right? So for 8, if I write, I get 1 0 0 0. For 12 in binary, what I'll be getting, 11 1 0 0. And for 16, I'll be getting 1 and 4 zeros, right? So let me align them properly so that it will be easier for all of us. So we want two zeros, right? Over here, we want 1 0. I want to keep the number of bits same. That's the reason I'm doing it like this. So it will be better for all of you to understand. Yeah. So I hope guys this is fine. Let me just put it up. Now we will visualize our approach with the help of these numbers. Okay. Okay. So how do we convert, like, in, if I want to convert it into decimal numbers, like if I want to go from here to here, what I do, I take the powers of 2, multiply it with the corresponding bit and add, right? Let's say if I want to convert this 16 to this again, so what I do, 2 to the power 0 multiplied with 0, and finally 2 to the power 4 multiplied with 1. See, this is very basic, but why am I writing? Because I want you to show that most significant bits are going to play better, means larger role. Means this 4, this 3, then this 2, see, it's descending, right? So can I say if I start padding up once from my most significant bit, I am sure that I'm generating bigger numbers. This thing should be clear in your mind, right? And finally, you add all of this, right? You add all of this, then you get 16, right? Like simple conversion. So you need to understand one thing, that whatever we start padding up from the most significant bit end, basically from left end towards right, if I start padding up once, I'll get bigger numbers, so on and so forth, right? Like what I mean to say is 4100 is greater than 140 and 1. All these are in binary, guys. Okay. So this is what I wanted to convey. Like if you have a look at this only, let's say you have 8, okay, and you have padded two ones, so obviously 12 is greater than 8, right? So this is, I wanted to show it to you because we will be using this concept. Okay, great. Now let me come to straight away the logic, okay, what I'm thinking. So in order to explain to you, I will take only four, basically 5 bits, 1 2 3 4 5, okay, and I'll be starting from the most significant bit. Okay, I'll be starting from the most significant bit. So let me show you a few lines of pseudocode, then we will come to the approach. Okay, means basically, or rather, I'll discuss the approach along with the code. Okay, so I hope this intuition is clear, right? Why we are starting from the most significant bit end, because somewhere I'll keep a track of the maximum with the help of that. Okay, so it will somewhat look like for int I equals to 4. Okay, I'm specifically discussing for this. I'm not going to the general test case of the question right now. So I'll go till the last or the least significant bit, and every time I do I minus minus. Okay, basically I start from here. So if I do the indexing 0 1 2 3 and 4, right? Great. So I start from the this bit, and I go towards the end. Okay, my means at least my visualization is in that way. Okay, after this, what I'm going to do is I will try to check at this bit. Okay, at this bit, or if I talk more precisely, at fourth bit in terms of indexing. Okay, what are the numbers that have ones? Okay, what are the numbers that have ones? If I get at least two such numbers, I know that I have a pair and I can have it in my answer. I think all of you will agree with me on this, right? Like at the fourth bit, if I have, means for more than two numbers or at least two, okay, two or greater than two, if I have one, I can say that it can be a part of my answer, right? A potential answer. Means later on I will see how can I update it, but it can be a part of my potential answer. And I'm going from this end because I want to make sure that every time I have the maximum with me. Okay, so This is what I'm going to do. So for that, let's say I have a function which is count num. Okay, this is counting what it is counting, how many numbers I'm getting where fourth bit is set to 1. Okay, as simple as that. So I'll be passing three things. Okay, first, what I want to match. So what I want to match, can I say if I want to match fourth bit is set to 1 or not? I can pass something like this. Fourth bit in terms of indexing, guys. Okay, I'm repeating again and again. So this is in terms of indexing, this is fourth bit. If I pass this to a function along with my array and size of array. Okay, so in that function I will simply compare. Okay, simply compare that all the elements of my array, okay, are equal to this pattern or not. Initialized as the size of bits. Akshat, I did not get your question properly. Basically, size of bits, I didn't get it. I am saying that I will be starting from I equals to 4, because I know that we have 5 bits, and if I do the indexing, it's from 0 to 4. And initially I want to check, like my aim is, for the time being, my short goal is, I'll be checking whether this bit, okay, fourth bit is set for how many numbers. Okay, if it is at least set for greater than or equals to two numbers, my purpose is satisfied as of now, because they can be my potential answers. Okay, so this is what I wanted to convey. So let me just write the pseudocode. Okay, little bit of pseudocode, you will get to know what I'm saying. So there is a function, count num is the function. Okay, and I am passing over here. See what I am passing, I'll write. I have taken a res variable. Okay, and I have initialized it with 0. Okay, and what I'll be doing one left shift I. Okay, and I will OR this with res. Now, guys, please have a look at this for a moment. What is going to happen? One left shift I, basically one left shift 4. This is nothing but 2 to the power 4, right? So it becomes 16 if you left shift 1 4 times. Basically, how does one looks like? This, right? You left shift 4 times. 1, 2, 3, 4. It goes over here and it becomes 16, right? So this will help me to pass 16. If I write something like this, why am I doing or with res? We'll get clear in a moment. Okay, don't worry about that. Like I could have just passed one left shift I. Okay, for the time being, as per my current explanation. But just bear with me for a moment. I'll explain why am I doing or with it. Okay. So I have done res or one left shift I, and after that I have arr and n. That's it. Okay, let's say this returns me something. Let's say it returns me in variable c. Okay, let me just zoom out a bit. In variable c, I am getting the count of nums, which is exactly equal to this pattern. Okay, this pattern. So obviously I'll be getting 1 because only 16 will satisfy. But I need a pair, right? So I need a pair. So I'll write something like, if my c is greater than equals to 2, then only I'm interested. Okay, if my c is greater than equals to 2, then only I'm interested. So if my c is greater than 2, can I say that I have got a pair, or at least I have got two numbers. I can get more than two also, because see, if I had 16, if I take 17 also, okay, then I'll get two. Means I'm saying that I need at least a pair, right? So what I'm going to do at that point of time, I'm going to update my res. Okay, I'm going to update my res. So basically, res is equals to res or one left shift I. Basically, I'll update that value of res what I passed. Now, guys, for those who have doubts, like why have I updated it? Why have I passed res or okay? Why have I have not just passed one left shift I? I'm going to answer all those questions now with the help of one simple dry run. Okay, because that will give you a feel. Anyways, I have told in the beginning that I am trying to go from the leftmost end. Okay, but still, in order to give you the exact feel, why am I updating, why have I taken res or okay, you'll realize now. Okay, so let me take this input and let me explain it to you. So Let me just clear some portion of the screen. And don't worry how we are doing this count num implementation, we will see. Okay, that is fairly pretty simple. I'm just running a for loop on all my elements, doing ampersand with this pattern and checking if it is equal to the pattern or not. Okay, that's it. And if it is equal, I'm doing a count plus plus every time. We'll see that, don't worry. Let me just do a dry run of this code and let's see how this works. Fine. So initially my I is 4, right? Just a second. See, just to brief you, we know that my res is going to become a basically this pattern is going to become a potential answer when my c greater than equals to 2 comes for me from count num. So I need to store that, right? So that is a possible candidate. Hence, I'm doing or, and there are few more reasons we'll see. Okay, so let's start. So initially I equals to 4, right? When my I equals to 4, my res is 0, right? Great. So yeah, let me have a look at the comments. Are there any? Okay, so Dhananjay has answered few of them. Okay, Akshat. So I is initialized as the size of the bits. Akshat, I is actually initialized with let's say you have an array is given to you. So whatever maximum number you have in your array, okay, you need to take log of that and you need to find out what's that value is coming, and that means in the order of log only you need to take. What I'm trying to say is, if I try to speak in very simpler terms, let's say I get a number x, okay, and there are a few more numbers, but let's say x is the maximum all of them. What I'll do, I will see in binary how many bits I need, how many bits I need to represent this x. Okay, whatever bits I need to go through all the bits, right? So over here, if you observe, I needed 5 bits. So if the indexing is from 0, how do I need to go? I need to go from 4, 3, 2, 1, 0. Okay, so that is how you should initialize your I. Is this clear? We will come to that. Okay, this will not remain 4 when we run our code on the Geeks for Geeks practice portal. Over here I have taken 4 because 16 is the maximum number and I need 5 bits to represent it. If I do the indexing, it is from 0 to 4. Okay, that's it. So I hope, Akshat, the doubt is clear, right? Okay, guys, so I was 4, res was 0 initially, right? So I go for count num. What count I'll get? If I go, I'll get count equals to 1 only, right? So this will become false. Okay, and my res, just a second. Yeah, and my res will still remain 0, right? Res will not get updated. Okay, so res is not getting updated. I go to the next time. This time my I becomes 3. Okay, and what I'm going to pass this time, 1 left shift of I. Okay, so yeah, I just missed out on this. Before, in the previous iteration, I was passing 1 left shift with 4. So this was passing 16 and I got a count as 1 when my I was 4, right? So as the count was 1, or let me take it as C. The C was 1. So that's the reason we did not updated our res. But the next time when my I becomes 3, so 1 left shift 3 we are going to do, right? Because my res is still 3. So 1 left shift 3, if I'm doing it, it's giving me 8, right? Okay, and I hope you understand this OR operation. See, these are very basic things. That's the reason I'm not going in detail. So if you do OR with 0 of res, so this is what you are going to get, right? So you will again get 8 only. So for 8, if you have a look, okay, what are you passing in this count num? Can I say you are passing this? So you're going to check with all the ARR elements. Can I match this exact equal pattern if I take ampersand of these two? So what I'm trying to say is, let me write in detail now. So you have the first number. Okay, you do an ampersand with 1,000. Right. Let me write it in vertical fashion. So 00100. You do it with this, right? So you are going to get a 0. Okay, so this is not the number. After that, you take the next number. Guys, I'm explaining how count num is working. Okay, so after that, I'm going to take 01000, and what I need to do, I need to again do the AND, right? So this gives me 1. Okay, all of these are 0, at least a non-zero value, right? Okay, if I go further, Yeah. If I go further, if I take for 12, suppose. So for 12, I have 0, double 1, double 0. And for 8, I have what I have 0, 1, triple 0. So this is also giving me 8, right? Some non-zero value. And for the 16, if you have a look, what are you getting? 1, 4 zeros, 0, 1, triple 0. You are getting 0, right? Like all will become 0. We are doing AND operation. Okay, these are all AND. So how many non-zeros you got? This one and this one, right? So these two, if I do an AND between them, 8 and 12, I know that I am getting a non-zero value, or basically I can say that the fourth bit, okay, in terms of indexing. Okay, just a second. Sorry, third bit, not fourth bit, because I equals to 3, right? 0, 1, 2, 3. Third bit in terms of indexing is set, or it's 1 for both of them, right? Great. So now my C will become 2, right? My C becomes 2. Yeah, Akshat, I was updating that actually. So for I equals to 3, my C becomes 2, right? Now when my C is 2, I know that 8 and 12 is a possible pair, right? So I need to update my res. So how am I doing that? See, I am doing or between the older value of res and what we have just now passed. So basically res will get updated with 8 if you observe properly. Like originally had zeros, and after that I do an or with one left shift I. So one left shift 3 is 8, and this is what I get. This is or operation, okay? Or operation. So your res is updated now, okay? Now guys, you're going to get a feel what I was saying, that from the MSB or from the most significant bit, if I try to have ones, then how we are getting the maximum number, okay? So this is 8. Great. Now let me proceed forward. So I equals to 3, C was 2. Okay, now my res has become 8, right? Great. Now if I go for I equals to 2, okay, let's say I go for I equals to 2. Now over here, what pattern I'm going to get? Can I say that in my older value of res I have 8? What I'm doing over here? Okay, I am ORing it with one left shift 2 times. Basically, one left shift 2 gives me 4, right? So if you do an OR now, you're going to get 12. Okay, this is what you're going to get. Okay, so we are going to get 12. And once we have this 12, what we are going to do, we are again going to check if this is equal to any patterns or not. Okay, so this will not be equal. See, not be equal. Basically, it will be equal only for exact 12. So count, we are going to get 1. All of them will give you zeros, right? Okay. Or I'll not say zeros. Okay, let me show it to you. Basically, what I mean to say is your res will not get updated. Let's say you have passed 12. Okay, so what's going to happen? Double 1, double 0 with 4, you are going to get this. Okay, so this is a non-zero value, right? This is a non-zero value, but this is not exactly equal to my pattern, right? So you need to return back only what are exactly equal to the patterns. Okay, so for 12 it will be only exactly equal. Okay, similarly, later point of time when your I becomes 1 and when your I becomes 0, it is not going to get updated. Okay, your maximum is going to still remain 8. I will show you one more test case at the end, okay, where if we put some more numbers to this, we can get some higher number, and we'll see how. Okay, so let's go to the Geeks for Geeks practice portal now, because it has already been huge time by now. Okay, I need to show the code over there, as well as make you visualize with few more test cases. Okay, so if you observe in this test case, we had this as the answer, right? So I have still not showed you how we are padding things up, right? Because if it would have been great if you would have got some more ones over here in our final answer, right? So we'll have a look at that. Don't worry. Let's go to the Geeks for Geeks practice portal. Okay. Yeah. So yeah, this was the first brute force approach which I have commented. After that, I am running from 31. Okay, so it depends. You can take a log of the maximum number and you can run your I from there. So according to the constants, I have chosen 31 because I have seen that I need 32 bits. So if I do the indexing 0 to 31, it will range, right? So I've started from 31 doing I minus minus and checking if it's greater than equal to 0 or not. Every time what I'm doing, I'm calling a function num with bit set, and I am passing my res or one left shift I. Okay, fine. So let's go to num with bit set function now. Okay, this is the first time you are seeing this, I guess. Yeah. So simple as I told, in count equals to 0, ignore this print statements. These were for debug purpose. After that, I am running a for loop, okay, on all the elements. And as I mentioned, I am doing the ARR I ampersand pattern and checking if it is exactly equals to pattern or not. Okay. I have count plus plus for exactly equal things and I return count. Right. Great. Fine. So that's it from here. And as soon as I come back over here, I check if I get at least two numbers which have the same orientation as the pattern which is passed, which is nothing but res or one left shift I. I am updating my res and finally returning it. Okay. So now let me show you a few things. Okay. So Anik is asking what is static int. So in Java, let me just brief you. Like if you are putting static inside, means if you're putting static in a function, then whatever you're calling from here, I'm calling num with bit set, right? So num with bit set, this should also be static. That is the reason static int is over here. Okay. Like from a static context, if you're calling another function, that should also be static. Okay, that's great. So this was more specific to Java syntax. Let me come back to the logic. Okay. So the logic is fairly simple. I check how many bits are there, or rather how many numbers are there, which exactly matches with the pattern. And if the number is at least 2 or greater than 2, I'm updating my res. Okay, and I'm returning it. Now, guys, let's try to understand with few more test cases, or I would rather say few interesting test cases where we will get a feel like how we can get a number, like how it is getting padded up from the left side, right? So before that, let me just submit it once. Okay, so we are getting TLE. Why? Just a second, let me check. Let's try to compile and run. Because brute force code is anyways commented. Okay, so this is fine. Int I equals to 0 num with bit set is working fine. After that, I have this and let's return. Okay, let's submit it once again. There are some issue at times. Okay, fine. So we got the correct answer, right? So that's great. Now let me put some debug statements, okay, because the time is less. So in order to make you visualize, let me put some debug statements, okay. So we'll see the value of res. We are going to see the, okay, let me check the value of count also, okay. What count I'm getting. Okay, fine. Okay, that's fine. Now let me put this as 4. Okay, I'm doing some changes to the code. And just for clarity, let me put some sort of separation. Okay, let's go for one custom input. So let's say after this I have 10. Okay, and I have 9 also, suppose, and this is a 6. Okay, fine. So let us look at our output. Okay, so initially, as you see, we have passed the pattern as 16, right? Because we have shifted how many times? We have shifted basically one left shift 4, right? So 16 count you got as 1. That's perfect. Because only 16 will have that bit set, right? Res is 0, right? After that, see what has happened. Your res has got updated. Your res has become 8. Why your res has become 8? Because you have passed 8 as pattern, and you will get from 8 and 12, I believe, the third bit which is set, right? and I guess from 10 also, and from 9 also, right? Because okay, let me show it to you on the whiteboard. Why the count is 4? Because 8 is how much? Let me write it over here itself. Just a second. If you have a look at 8, okay, let me take this. 8 is 1 000, right? And 12 is 1100. 10 is 1010. 9 is 1001, right? So you have this bit set, third index bit set in 4 of them, right? That's the reason you got 4, and you have updated your res with 8, because whatever combination you take, if you take 8 12, you will get it as a potential answer. If you take 8 10, still it's a potential answer, right? So just to give you an overview. Now let's go further and let's have a look at it. So after that, my pattern becomes 12 now. Okay. Why my pattern becomes 12? Because I updated my res with 8, right? Updated my res with 8, see. And in the next iteration, you're going to do an OR with 1 left shift 2, if you remember. We are doing it over here, right? Over here. So that is the reason it has become 12. This is 12. Now for 12, we are going to add a count of 1, only 12. So when you get a count of 1, you don't do anything, your rest still remains 8, right? Now let's go further. Okay, let me just clear this. Okay. Just a second, guys. Let's take an input because I means I would have shown this, but I see that still 8 is remaining the maximum. So what can I take? Just a second. Let me check few comments if there are. Okay, do I have any such test case? Okay, let's go with 11 ones. Yeah, because 10 and 11. Okay, 1010. Yeah, this time I think the answer should change. Okay. Yeah, so let's go down. Yeah, you're getting 10, right? So you are getting 10. How does 10 looks like? 10 is looking like 1010. So see, we have although started from the leftmost end, but that doesn't mean that all of this will be filled and you will get like all ones together, all zeros together. No, it's not like that. This is what I wanted to make you visualize. Okay. Like, see, I could have just ran the program and I could have said that it's done, but I wanted to give you this visualization. That's the reason I took this test case. Okay. So now let's have a look at it. What is going to happen? So let's say we're somewhere in midway, res is 8, right? So when res is 8, okay, and after that you have your pattern as 10. Okay. So when res was 8, okay, I am assuming, or let's not assume, let's go to exact. So we have I equals to 4 over here, right? Then 3, then 2, and then 1, right? Okay, so over here, my I is 1. Just a second. My I is 1, right? And res is 8. So what I'm doing, I am left shifting 1 times, right? That's what you have sent if you have visualized over here. Just a second. Basically changing multiple colors. That's what I have sent over here, right? So if you observe I equals to 1, your old value of res is 8, right? So this is 8. I equals to 1 is this. You are doing an OR. So this becomes 1010 because all these are zeros. That is the reason your pattern is becoming 10. So this is what I wanted to give you a feel that I am going from the most significant bit towards the left significant bit. And if it is required, I am updating my pattern. And if that comes to, or I'll not say if it is required, I'm updating my pattern every time. And I am checking from this end only, right? And why I got a 0 over here? Because res did not got updated and my I escaped. I escaped the values of in between. Like when straight away I came to 1, then I was able to change the values, right? Change the values of res basically. Okay, so guys, don't get confused. Try to do a dry run from your end, because eventually you'll realize that if your pattern is 10, you're getting two numbers. What are those two numbers? 1010 and 1011. Binary representation of 10 and binary representation of 11, right? That's the reason your count is becoming 2. And you have the res equals to 10, right? Because if you take the ampersand of this, okay, let me show that to you as well. This is your pattern, right? You have taken the ampersand, you're getting 1010. That is exactly equal to pattern. Now if you take for this, what will you get? 1011, and you are doing and with pattern. So this also gives me, see, these two are equal, right? So guys, I hope this is clear to you. This is making sense, right? So do let me know in the comments if you still have any doubts. Okay, this is what I wanted to make you visualize. Okay, and apart from that, till the end, nothing will get updated, and you finally return 10 as your answer. Okay, so let me just remove all the comments now. Okay. Yeah, guys, now you can come up with your doubts if you have any. So let's just submit it once again. Okay, let me check the comments. Okay, so what is wrong? This is wrong, right? It should be 31. Okay, let's submit it. Okay, that's great. This is getting submitted. That's really nice. Now I'll take questions if there are any. Okay, so thank you for such kind comments. I hope this is clear to everyone. Okay, yeah. So I'll just take few questions now if there are any. Okay. Okay, so yeah, I guess someone from the audience was asking the use of static, right? So please visit Geeks for Geeks Java channel. Okay, so you will understand basics of Java from there. So, but I have somewhere briefed, right, that static is used for mostly like keeping some constant variable sort of thing, or if you want to, let's say, share the same variable or method of a given class. Okay. And apart from that, guys, any questions related to the logic, like logic in this question? Okay, so Abhishek is asking, can you explain why we passed res or one left shift I to count function again? Okay, fine. So see, Abhishek, what I'm trying to say is, let me just share my screen. Okay, just a second. It's okay. It's okay. It's okay. Like if you have missed it, no issues. Either you can go back to the video and watch, or I'll explain it again. No issues. Okay. So just a second. Yeah. So I hope this is visible now. So over here you are asking, right? Why am I passing it again? See, you have got your answer in some iteration. Okay, in some iteration you have got your answer. Suppose. Okay, and later on you need to improvise on that answer, right? You need to improvise on that answer, right? So how we can do that? If I totally get rid of res, whatever previous answer I got, don't you think that is wrong? So in order to include that previous value of res, and also in order to make sure that I am moving from my most significant bit to the left to the least significant bit, what operator can I use? Can I say that I can use or, res or? Because whatever earlier value of res is there, see, let me open this. Earlier value of res was 8, right? I did or with means one left shift one, if you remember. So we got this. What if I would have not I would have not taken this into consideration? Then my res would have remained like means if I don't write res at all, so what will I be passing? I'll just be passing one left shift two. But that's not what I want, right? I also want to keep track of my old potential answers, right? So I needed the or of the old value of res. So as to ensure that I'm moving from the most significant bit to the least significant bit, or leftmost end to the rightmost end, right? To be more precise, most significant bit towards the least significant bit, right? So I hope Abhishek, this is clear to you now. Do a dry run from your end, okay? You will get to know it more better, okay? And if you still have doubts, okay, that's great if it's clear. Okay, guys, so that's great. Okay, yeah, great, guys. So thank you for such kind comments. Okay, that's it from my end for today. I'll see you in my next live stream. I hope I was able to add some value to the coding part of today. Okay. And if you have any doubt in today's explanation, do let me know in the comments. Okay. Be it related to explanation, syntax, or whatever it is. Okay. Regarding the question. Okay. Okay. That's great, guys. Then thank you. Thank you, guys. Thank you for joining Geeks for Geeks practice.